So we're going to do a competency exam review. I'm going to start with factoring polynomials. I'm going to list here on the side all the rules, most of the important rules for factoring. I'm going to start with the difference between two squares. A squared minus b squared, that's a minus b times a plus b. Difference between two cubes, that's a minus b times a squared plus ab plus b squared. When it comes to examples, I'm going to explain them more. And of course, it's either a difference or sum. So if it's sum, I'm going to put here plus. So what will change? This plus here, and this minus. Then we have perfect square trinomial. So we got a plus b all raised to 2. And you have these rules on the one of the sheets, I think I gave you. The orange one. Did I give you one? Like this? Do you all have it? No? Okay. Difference. Perfect square trinomial with the subtraction. So let's look at our first example, and I'm going to start with the ones where a in the trinomial has the a is a number other than 1. Any polynomial with 3 terms, we call it trinomial. So ax squared plus bx plus c, this we got 3 terms here, so it's a trinomial. To factor the trinomial, 3x squared plus 2x minus 16, I'm going to use the AC method. AC method. And it should be on one of these sheets. I should edit this. Yeah, I'll fix the video. You don't have this sheet? No? Okay. Pick one. And also, this is the AC method of factoring, and then the other one has more examples if you want to pick one when you leave. Forget about it now. Okay, so the AC method says what? I'm going to take the A, multiply it by the C, and that will give me 3 times negative 16. That's a negative 48. And then I'm going to break this negative 48 divided into 2 numbers. These 2 numbers, or these 2 factors, their product is negative 48 and their sum is positive 2. So the first 2 factors will come to mind. Mine is negative 6 and 8. If I multiply them, that's a negative 48. If I add them, that will be a positive 2. So what do I need them for? I'm going to take these 2 numbers and use them as a coefficient for the middle term that I want to split into 2 terms. So the 2x, I'm going to write it down as a negative 6x and a positive 8x, and then negative 16 will come down. So this 2x went all the way down, split into 2 terms. Now I'm going to factor by grouping the first 2 terms together and the second 2 terms together. So I will have a common factor inside the parentheses here, the first parenthesis, and this common factor is, the greatest common factor is 3x. I'm going to pull it outside from these 2 terms, That will leave me with x from the first term. When you take the 3 outside, it's not there anymore beside the x. And the x squared, when you take one x outside, the other x will stay. Or I could say 2, the exponent, minus the exponent here, which is 1. That's what's left. When you factor, it's actually you are dividing the terms, the original by the factor. And what's left is inside the parentheses, and that's a 2. The 6x here, we got 3x outside, and 2 will be left. Now let's look at the second parenthesis. I'm going to pick the 8, which is my greatest common factor between these two terms. So plus 8, open a parenthesis, that will leave me with just x here, and then the negative 16 will be negative 2. So we got before the plus a term and a big term after the plus also. So between these two terms, I got the x minus 2 as a common factor. I will pull it outside or factor it. You can start with the x minus 2, or it could be in the second spot, doesn't matter. It's a product. And 3x is left from the first big term, and 8 left from the second big term. So these are my two factors. We call this factoring. And then if I go and check my answer and multiply these two, we call it what? Foiling, right? So factoring opposite to foiling. That's our first example. Okay, let's start with this first rule. This is factoring using the AC method. It's not right here, but it's on one of the sheets. When you pick it up, you will see more examples. Now let's look at our next example here. I have 4 minus 36x squared, a difference between two perfect squares. How do I know that they are perfect squares? As soon as I see the exponent 2 and these two numbers are perfect squares. The 4 is a product of 2 by 2 and the 36 is 6 by 6. So first step, I'm going to write both of them as perfect squares where I can see the exponent on top of the whole term, all of it. So instead of 4, I'm going to write it as a 2 squared. And instead of 36x, I'm going to write it as a 6x all raised to 2, because this 2 is over on top of x only. And why did I do that? So I can match with my formula. So the a here is 2, the b is 6x. So 2 minus 6x times 2 plus 6x. I still have something in common inside the parentheses, which is here is what? 2. In each one of them, it's 2. So there is two ways to do this problem. And sometimes if you feel that you can do the question or answer the question in shorter number of steps, that's fine. You can use your own method. I am familiar with all different kind of methods to solve these kind of topics or examples that we're going to do during the whole semester. So right here, what I did, I used the perfect difference between two squares formula, and then I'm going to factor a 2 from the first and the second parenthesis, and that will leave me with 1 minus 3x, 1 plus 3x. Okay, so I can factor the 2 here. I can factor the 2, and that will leave me 1 minus 3x. And also, I can factor another 2 from here, so I will leave me with 1 plus 3x. And that final factoring step will be right here. Or from the beginning, I can do it in a different way. Let me scroll this out. I can pick the least common, the greatest common factor between these two terms, which is 4. And that will leave me with 1 minus 9x squared. And then I factor what's between the parentheses as difference between two squares, which is 1 minus 3x and 1 plus 3x. Okay? So I just want to show you the long way, because maybe some of you will start right away by using the formula and forget about factoring the 4. Okay, let's do one with the cube formula. So I have here 24x cubed plus 3y cubed. First of all, I'm not going to do it the long way. I'm going to pick the factor, the greatest common factor here, which is 3. So I'm going to take the 3 outside. That will leave me with 8x cubed plus y cubed. And then use the sum of two cubes formula. So first of all, I want to see the cube on the whole term. So I'm going to write this 8 as 2, and then put the cube on the top, and the y stays cube. I'm going to pull the 3 all the way at the end. Using the formula, the a is my 2x, the b is my y. Then the second factor is the one with 3 terms, 1, 2, 3, longer. So without memorizing the formula, by the way, when it's a sum of two cubes, you pick the same a and b without the exponent in the first factor. This is the 2x and the y, without the 3. And then in the second factor, you're going to square the first term, so it's a 4x squared. You're going to square the second term, so it's a y squared. In the middle here, first times second. That's all. First times second. But I'm going to multiply them both together, 2xy, with an opposite sign. So you don't memorize actually the formula. If it's addition, you pull exactly what you have in the two terms, and then the second factor will be based on the first term. You square first, you square second, and you multiply first by second with an opposite sign. And that's our final answer. Just pull the 3 down.